In this video, we're going to have a look at probability. To calculate the probability of an event, meaning that an experiment will have a specific outcome, we take the number of possible ways for the event to happen, and we divide that by the total number of outcomes for the experiment. So if we were to calculate the probability that a die will land on 6, we know that only one of the sides of the die has a 6 on it, and in total there are 6 possible sides that it can land on. So the probability is 1 out of 6. Probability is measured on a scale between 0 and 1. So if we say that something cannot happen at all, if it's impossible, the probability is 0. And if the probability is 1, it is certain that this will occur. Even chance, 1 out of 2, means there's a 50-50 chance that it will occur. Any probability between 0 and 1/2 is something that is unlikely to happen, and between 1/2 and 1 is likely to happen. Let's go and have a look at some examples. A bag filled with chocolates contains 5 bar 1, 7 ticks, and 3 Aero chocolate. 1 chocolate is taken out at random. Determine the probability that you remove a bar 1. So we want to determine the probability P to remove a bar 1 from the bag. The number of outcomes for our event is any of the 5 bar 1s in the bag. And this is divided by the total possible outcomes, and that is the 5 bar 1s plus the 7 ticks and 3 Aeros, so that's 15. So the probability is 1 out of 3. Question 2. Determine the probability that you will remove a Tex or Aero chocolate. So for the probability of removing a Tex or an Aero chocolate, we can take one of the 7 ticks or one of the 3 Aeros. So our total number of outcomes for our event is 10 different outcomes out of the 15 chocolates, and that is a probability of 2/3. There are 52 cards in a pack, excluding the joker. Determine the probability that you draw a king. In a pack or deck of cards, we have 4 different suits. We have the heart, diamond, clover, and spade. Each suit starts with an ace, then the numbers 2 up to 10, and after 10 we have the jack, queen, and king. That is a total of 13 cards per suit. So if we are asked to determine the probability to draw a king, we know that in total there are 52 possible outcomes. In every single suit we have a king, which means we have 4 different possible suits to remove. Simplified, this is 1 out of 13. Question 2. Determine the probability that you draw a heart. So, for the probability to remove a heart from the pack, we know that we have 13 different heart cards, and that is out of the total of 52, which simplified gives us a probability of 1/4. Question 3. Determine the probability that you will draw a heart or a 3. To determine this probability, we are still going to work with all 52 cards. We can remove one of the 13 hearts or any card with a 3 on. That means we have the 3 of hearts or the 3 of clovers, the 3 of diamonds, or the 3 of spades. But now you need to realize that we already counted the 3 of hearts in the 13 heart cards. In total, that means we have those 13 plus another 3 options, and that is 16 options for our event to occur. Simplified, this is a probability of 4 over 13. Let's have a look at the difference between relative frequency, where we do a calculation after the experiment, and probability, where we do a calculation before the experiment. I'm again going to make use of the example of rolling a dice. Before the experiment, we can predict that the probability of it landing on a 5 is one possibility out of the total of 6 possible sites. As a decimal, this is a probability of 0,167. In this table, we now have the results after a dice has been rolled 60 and 200 times. From here, we can calculate the relative frequency for the dice landing on a 5. When the dice was rolled 60 times, 9 out of those 60 times we had a 5, and that's a relative frequency of 0,15. In the second experiment, where the dice was rolled 200 times, to get a 5 happened 33 times out of the 200, and this is a relative frequency in decimal form of 0,165. Can you see that when we increased the number of rolls, the relative frequency moved closer and closer to the probability that we predicted? So remember that a probability is simply a prediction. The more times you repeat an experiment, the closer to that prediction your relative frequency or your reality will be.